All right, guys, let's see. We're on number 8 right now. Okay, so let me put this here, the number 8. F of x equals the square root of x squared minus 16. Okay, let me get that out of the way. All right, so here's what we need right here. We're working with real numbers, so I have to keep this radicand. This guy has to be greater than or equal to 0, okay? Because if it's negative, then I end up in the complex number system, okay? So what I want to do is start by taking that radicand, setting it equal to 0, and then solving for those two solutions. So I say x squared minus 16 equals 0. Now you could use square roots to solve for these. I'm going to just factor because that's the difference of squares. So I have x plus 4 times x minus 4 equals 0. Okay, so I get x equals negative 4 and x equals 4. All right, now what I want to do is I go to a number line. Okay, and I'm going to explain this in a second. Hopefully I've had a chance to explain this, okay, in class. Okay, and so we have negative 4 and we have positive 4. Okay, so we have 3 different regions on the number line. Okay, everything from negative infinity up to negative 4 right here. Okay, everything from positive 4 to positive infinity right there, and then in between everything from negative 4 to 4. Okay, so what happens is that this function, x squared minus 16, will either always be positive or always be negative in each interval. Okay, so down here to the left of negative 4, this function is either always positive or always negative, one or the other. Same thing in here, between negative 4 and 4, the function, the y values, will either all be positive or all be negative, one or the other. And the same thing here. Okay, once we get to the right of 4 on the number line, the y values will either all be positive or all be negative. Okay, this function can only change sign at these points. Okay, that's actually something you learn about in calculus. Okay, but it's actually the easiest way to do this. Okay, so right here I can take any random value for x and use it to figure out, well, is my radicand positive or negative? I can do the same thing in here, take any random value of x in that interval, okay, and figure out, will my radicand be positive or negative in that interval? And I can do the same thing here. Okay, so I look down here and I say, okay, well, why not just choose x equals negative 5 here? I could choose anything from negative infinity to negative 4 I could choose. In here, I'm going to choose x equals 0. Okay, and again, I can choose any value at all in there, and it'll tell me what to do. And here I'm going to change, since I chose negative 5 down here, I'll choose positive 5 here. Okay, and then we just have to look at the value of the radicand. Okay, so here I go, negative 5 squared minus 16. So I'm going to get 25 minus 16, which obviously is 9. So notice that means that everywhere, no matter what value I choose for x in here, it's going to spit out a positive y value. Okay, here I use x equals 0. So I get 0 squared minus 16, which obviously gives me 0 minus 16, which is negative 16. Okay, so that means that no matter what value I choose in here, okay, for x, it's always going to spit back a negative y value. Do the same thing here. Take 5 squared minus 16, so that gives me 25 minus 16, so I get a positive 9. Okay, so that means no matter what y value I choose in this interval, okay, it's going to spit out a positive result. Now remember, okay, we want this x squared minus 16 to be greater than or equal to 0. Okay, so we definitely want to include this guy right here. We definitely want to include this guy right here. And this guy is throwaway. The reason we're throwing him away is because it's going to give me a y value that's negative, which would bump me out of the real numbers into the set of complex numbers. Okay, so now it's just a matter of, do I keep this guy and do I keep this guy? Okay? Well, when x equals -4, notice I'm going to get -4 squared minus 16. That's 16 minus 16, which is 0. Now notice that works because the square root of 0 is just 0. Okay, so I want to keep this guy. Okay, and over here I do the same thing. So I'm going to get 4 squared minus 16, which is 16 minus 16, which again is 0. And again, there's nothing wrong. The square root of 0 is 0, so I want to keep this guy. Okay, so in my domain, okay, I want all of these numbers along with -4, and I want all of these numbers along with 4. So everything that gets thrown out is everything between -4 and 4. Okay, so we could say, okay, my domain goes from -infinity to -4, and we include -4, and then we throw all this out, and it starts back up at 4. And then it goes from 4 to infinity, and we include 4. And then we just union those guys. That's it. That's the easiest way to represent it. Okay, easiest way. Okay, now if you wanted to do set builder notation, it's probably a couple different ways you could do it. Okay, we could say all numbers x such that. Well, wouldn't all these values be less than or equal to -4? So we could say x is less than or equal to -4. Okay, union that with, couldn't we write that as all numbers greater than or equal to 4? X is greater than or equal to 4, and x is obviously a real number. Okay, again, either one of them is good. I like the interval notation there. Okay. All right, let's see what's happening here. Okay, now this guy is very similar to number 8, but not exactly the same. This is number 9, so I have f of x equals. Okay, I have 5x up above, and I have the square root of x squared plus 6x plus 8 down below. All right, now, remember up here, we talked about that radicand could be greater than or equal to 0, because we can take the square root of 0 and it just gives us 0, so it's no big deal. But remember, that function is in the numerator. Well, down here, the function is in the denominator. So if I let that radicand be 0, I would have the square root of 0 down in the denominator, and we can't divide by 0. So this guy right here has to be strictly greater than 0. Can't be equal to 0, because when you try to divide by 0, it doesn't work. Can't do it. Okay, so let's see. All right, so I'm going to start it the same way. I want to work on a number line, so I have to find what solutions I have. Okay, so I look at x squared plus 6x plus 8 equal to 0. And that guy factors into x plus 4 times x plus 2 equals 0. Okay, so I get x equals -4 and x equals -2. Okay, so I take those values to my number line, just like I did on the last one. Okay, and so we have a -4 and we have a -2. So those two solutions, okay, to this quadratic equation splits it up into 3 regions on the number line. I have from -infinity all the way to -4. Okay, I have from -4 all the way to -2, and then I have from -2 to infinity. Okay, and once again, this value right here, this radicand, can only change signs at these 2 values. So everything down here will either give us a positive or a negative. Everything in here will always either give us a positive or a negative. Everything in here will always give us either a positive or a negative. So I can just take these random values. Okay, so I'm going to use x equals -5 here. Right here, I'm going to use x equals -3 there, and right here I'm going to use x equals 0. Now you don't have to use those values. You could use some other value in those intervals. That's up to you. Okay, so let's see what happens here. So I get negative 5 squared plus 6 times negative 5 plus 8. So that gives me 25 minus 30 plus 8. So that's going to give me, what, positive 3? Okay, so that means every y value in this interval is positive. Okay. So we want to keep this guy, obviously. Okay, because once again, we want that radicand to be strictly greater than 0. Okay, so right here I use negative 3. Okay, so I get a negative 3 squared minus 6 times negative 3. Okay, and then plus 8. So that gives me 9. Okay, wait a minute. That's a plus right there. I take that back. That's a plus. Okay, 9 minus 18 plus 8. So that's going to give me negative 9 plus 8, which is negative 1. So that means everything in this interval will give me a negative y value. Okay, so that means I want to throw this guy away. Throw away. Okay. All right, now we're using x equals 0 here. So I get a 0 squared plus 6 times 0 plus 8. So that gives me 0 plus 0 plus 8, which gives me 8. So that means I'm always going to have positive y value. So we want to keep this guy. Okay, I want to keep him. So I want to keep this interval, I want to keep this interval, I want to throw that guy away. Now we just take a look at, well, what happens here and what happens here. Okay, so if I take negative 4, I'm going to get negative 4 squared plus 6 times negative 4 plus 8, which gives me 16 minus 24 plus 8. That is 0. Now I can't have 0 down in the denominator. That'd be the square root of 0 equals 0, so I'd have something over 0. I can't divide by 0. Okay, so we need to throw that guy away. Okay, so that's a throw away. Now the same thing's going to happen here. Okay, when I take negative 2, I go negative 2 squared plus 6 times negative 2 plus 8. So that gives me 4 minus 12 plus 8, which equals 0. So again, I can't have 0 in the denominator, so that's throw away. Okay, so negative 4 gets thrown out, negative 2 gets thrown out, and everything in between them gets thrown out. So I just keep this and I just keep this. Okay, so my domain, I'll go up here, my domain will be this interval, not including negative 4, so we go from negative infinity to negative 4, along with this interval, not including negative 2, so I go from negative 2 to positive infinity, and then we just union those guys. Okay, so there's interval notation. If I want to do set builder notation, I could say all numbers x such that x is, wouldn't this be strictly less than negative 4? And wouldn't this be strictly greater than 2? And then we just union those guys. And obviously x is any real number. Okay? Both of those are good representations for the domain. I'd probably go with the interval notation right there. Okay, so you got to be careful with problems like 8 and 9. This is usually where if students have problems, they have problems with these radicals. Okay, so you got to be real careful with those guys.